This series of videos is going to go through the chapter 5 of Radians in the Year 2 Pure textbook, focusing on the Edexcel spec, but will be similar to the other specifications as well. I'm going to introduce you to what Radians are in this section, but I'm going to have several videos going through each of the kind of parts that follow the Edexcel textbook. So, what are radians? Well, before we actually mention what they are, I just want to remind you of the sine rule, the cosine rule, and the formula for the area of a triangle, because we are going to be needing to use these in some of our radians work. We did some work in year 1 on kind of the GCSE work really, but just to bear in mind that these formulae still work whether you are working in degrees that we've always worked in the past, or now possibly radians as we go towards the year 13 exams. So a over sine A equals b over sine B equals c over sine C if you're looking for a side, and the reciprocal of those fractions if we're looking for the angle. A squared equals b squared plus c squared minus 2bc cos A for the cosine rule, and the area of a triangle is half AB sine C. So all three of these work whether we are working in degrees or in radians. So a radian is an angle. We've always worked in degrees until today, but we can use another measurement instead. It's like using miles and kilometers or pounds and grams. It's another way to measure an angle, and the reason we do this is because it actually makes working out things to do with areas of circles or arc lengths really straightforward, and you'll see that in a video or two's time. But that's the reasoning. That's one of the reasons behind it. It also makes this when we do integration, it makes the scaling correct for finding the areas under trig curves. So when we do come to work out integration with trig, which will be in a few chapters time, we will need to make sure that we are working in radians rather than degrees, so that the answers are correct. I'll try and remember to say that when we get onto integration with trig later in the year. So this is the conversion. Like I said, it's just a different unit measurement. So miles to kilometers has a conversion. Degrees to radians has a conversion too, and 180 degrees is exactly the same as pi radians. Okay, that's really important. Please remember that in all of your work. 180 degrees is equal to pi radians. And what you'll probably find yourself doing at first is when I say 3 pi over 4 radians, you'll probably be thinking in your head, how many degrees is that? And what you want to try and do is you want to try and ease yourself out of doing that, of making yourself convert back to degrees every time. Try not to convert back to degrees every time. Try and just get more comfortable as often as you can working with radians. It's absolutely correct and good to be working with 3 pi over 4 radians. There's nothing wrong with that. So try not to keep converting it back to degrees in your head. Try and stick with degrees if they give you degrees, and try and stick with radians if they give you radians. And they'll tell you in the question each time if you are working with degrees or if you're working with radians, or there'll be clues that you are anyway. So let's just go through a couple of conversions to try and get more comfortable with working in radians. If 180 degrees is equal to pi radians, then 360 degrees will be equal to 2 pi radians. And you can write rads, or you can put a little r, or you can write radians. 90 degrees is going to be half of that, so pi over 2 or a half pi radians. 45 degrees is half again, so that's going to be pi over 4 radians. 30 degrees, well, we can use the 90 to help us. That's going to be a third of 90 degrees, so it's going to be a third of pi over 2, so that's pi over 6 radians. And what's 1 degree? 1 degree is going to be pi divided by 180 radians. You rarely use that. I wouldn't bother learning that. I would just remember that 180 degrees equals pi radians, and if you needed, say, I don't know, 17 degrees, I would go from here, I would write this step down, and then I'd be able to say that 17 degrees is equal to 17 pi over 180 radians. Sometimes if we are working in radians, they will want you to leave your radians in exact form. So it would, the correct answer would be 17 pi over 180. Now remember, pi is the same pi that we've always worked with. It's not a symbol, it's still that 3.14. Sometimes people aren't sure about that. So if we were to work out what 17 pi over 180 radians was, we would just use the pi button on our calculator and we would get an actual value. So 17 pi over 180 is 0.2967. That's the angle we would use if we wanted our answer in decimal form. Okay. Conversely, 1 radian, if we wanted 1 radian rather than 1 degree, that would be the reciprocal of pi over 180. So it would be 180 over pi degrees. That's less likely to be needed. We're unlikely to want 3 radians. 3 radians isn't a useful measurement. We tend to want multiples or fractions of pi. So this is less likely to be asked about, but this is something you might need, and definitely these numbers at the top you're going to be seeing over the next year lots of pi over 2s, pi over 4s, 3 pi over 2s, 5 pi over 6, and all that kind of stuff. So try and get used to writing angles as fractions of pi or multiples of pi. As I said, though, the sine, cosine rule and area of a triangle rules all work in radians. If you had an area of a triangle that you wanted to find out, you wouldn't need to, and you were given the angle in radians, you wouldn't need to convert that into degrees and then work our answer out like we would have last year or at GCSE. All we need to do is change the calculator into radians mode. And I've just got the steps of how to do that if you have a ClassWiz, which I'm guessing is the most likely calculator that you've got. It's really simple. Once your calculator's turned on, just in normal calculation mode, you would press Shift and then Set Up, and then that would give you the option to choose the angle unit. I've written angle mode there, that should say angle unit, which is option 2, and then you would choose option 2 again to change it to radians. So I've just done that on my calculator. My calculator is now set up to work in radians. So if I wanted to find out the area of a triangle, but I was given the angle between the two sides in radians, say I was given that it was pi over 6 radians, then I would just use pi over 6. I wouldn't convert that to how many degrees it was and work out it in degrees. I would keep it in radians. You will find yourself, now that we've come on to the radians chapter, you will find yourself needing to especially when you're doing exam questions, you'll need to switch between degrees and radians. So always check, if it's a trig question, check, do I need my calculator to be in degrees or in radians if I'm going to need to use my calculator. That's a common mistake. Once we've now kind of entered the world of radians, people sometimes forget to switch between radians and degrees in their calculator. So just a few example questions before you are able to work through exercise 5A. Just a couple of conversions. 40 degrees, turn it into radians. Well, because we know that pi radians is 180 degrees, we can say that 1 degree is pi over 180. So 40 degrees will be 40 pi over 180, and we would simplify that. Don't leave that as your answer. That will cancel down to 4 pi over 18 or 2 pi over 9 radians. And notice in the question I've asked for the answer in terms of pi, in exact form. You will find that most of your answers will be required in exact form, which means your calculator is not going to be terribly useful other than for doing things like cancelling down your fractions. Getting used to drawing graphs in radian form is really important. I know this is radians because I've got pi in my range of values of x rather than 180 degrees there. So that is sometimes the only clue that you'll get that tells you you're working in radians rather than degrees. 0 to 2 pi is, I know in your heads you're all going to be saying, well, that's 0 to 360. So there's my 2 pi. Pi would go there. That value would be pi over 2. And this value would be 3 pi over 2. We should probably put the 1 and the minus 1 on as well. So that's the kind of thing I want you to get used to doing. I don't want you thinking 180, 360. I want you to be able to be as good at drawing in radians as you are at drawing in degrees. Okay, working backwards, working the other way around, or in fact, not quite working backwards, but working out an exact value. I know you could pick your calculators up right now, but I don't want you to. We have some exact values of sine, cos and tan when working in degrees, but do we have some exact values when working in radians? Well, we do, because we've got the conversions. So if I draw our table, and some of you are really good at remembering these and some of you are not so good. I've got my sine, cos and tan. Let's do 0, 30 degrees, and we'll write down what they are in radians in a minute. 45 degrees, 60 degrees, 90 degrees. Easiest to work out this one, that's pi over 2. That's this middle one here is pi over 4. This will be pi over 6, and this is pi over 3. So all these values that you hopefully know already are now also the exact values when we're working in radians too for these values. So we can fill in our exact values. Sine of 0 is still 0, cos of 0 is 1, and tan of 0 is 0. For the next row, sine of 30, so now sine of pi over 6. Well, sine of 30 you hopefully know. It doesn't really matter if you forget because you've got your calculator, but that one's a half. cos of 30, so now cos of pi over 6 is root 3 over 2. And tan of 30, so tan of pi over 6 is 1 over root 3. Or if you do that one on your calculator, that will come out as root 3 over 3. For the next row, we've got 45. Sine of 45 is 1 over root 2. Again, your calculator would give that as root 2 over 2. That's the same for cos of 45, so cos of pi over 4, 1 over root 2, or root 2 over 2. And tan of 45 is 1. Sine of 60, so sine of pi over 3 is root 3 over 2. Cos of root pi over 3, cos of pi over 3 is half, and tan of pi over 3 is root 3. And sine of 90 we know is 1, cos of 90, so cos of pi over 2 is 0, and tan of 90 is an asymptote, so that's not defined. So all those, as I said, all those values for degrees are now available to us for radians as well. This actual question wanted cos of pi over 4, so cos of pi over 4 is equal to 1 over root 2. So you should now be able to work through exercise 5A. It starts on page 116 in the Edexcel textbook, or as I said before, for any other exam board that you're working on, you should now be able to do the first section in your Radians chapter. If you've got any questions, leave me a comment or send me an email if I'm your teacher, or send me a comment on Show My Homework.